Okay, in this video, we're going to switch topic a bit. So now we're going to talk about how you can join data frames. This can be an extremely useful tool for you to know about and learn how to use when you work with data and pre-process data. So the reason why it can be extremely useful is that when you work with data, the data rarely comes in a form where it's just ready for analysis. In particular, it will often come in different pieces. And these pieces you will need to merge them or join them together somehow in an appropriate way for your analysis. And this is what you're going to learn more about in this video. Okay, so until now we've only worked with one data frame at a time. Basically, there was one exception, and that was when you used concat to concatenate different data frames in assignment 0. So what you did in assignment 0 was that you had different data frames with weather data from satellites in different years. And then you basically just want to stack them on top of each other to create a new data frame. So that's what you used concat for in assignment 0. You will learn much more about this type of operations in this video. And in order to illustrate what we will be doing, we will use the multi-column display from Jake van der Plas that's implemented with the code down here. There is an associated blog post that I really suggest that you take a look at. I think it's written in a very nice way. It's not very long, but it provides some very useful intuition for what we're doing when we're using these different operations that I'm going to show you in this video. So I really suggest that you take a look at it. It's very good, I think, and very easy to understand. Okay, so let's get started. And in order to get started, we need to create some data to play with. And here we're using the dictionary-based approach for creating data frames that I also used in the previous video. So here first we create a left data frame using the pandas data frame constructor. And here you create two different variables, two different columns of data. So I have a column called key where the values are called A, B, C, D. And then I have a value left column where the values are simply 0, 1, 2, and 3. Then also create a right data frame using the pandas data frame constructor. I again have a column that's called key that has values C, D, E, and F. So you can see there's some degree of overlap with the keys in the left data frame. And then the values associated with this right data frame is values going from 4 to 8, excluding 8. So here I'm displaying the two different data frames that I get out of doing this. So now we're going to try and merge these two data frames in different ways using the merge method that comes with pandas. And we're going to use the following convention for illustrating what's going on. So whenever you have something that's blue in the figures, it represents rows in the merge output, rows that we can see in the merge, with rows with data that you can see in the merge output. Something that's red will be rows that are excluded from the output, and rows that are green will be rows that are basically created with missing values in them. Okay, so let's start with an inner merge. That's a default type of merge. So this inner merge only uses shared keys. So it will basically use the intersection of the two data frames that share the same keys. And in order to show how this works, consider the following. Yeah, so I'm creating a data frame called inner merge using the merge method in pandas. Then I'm specifying that I want to merge the data frame left and the data frame right, and I want to merge them on the key variable. And then here I specify directly that I want to make an inner merge. And here you can see what I get out of doing this merge. So basically what I have here is only the observations in each data frame that are associated with keys that are present in both data frames. So as you could see, there was an overlap in the key values in the left data frame and the right data frame, and that was key C and D. And here I only keep the values that were associated with these two different key values. And then I have the values from the left data frame and I have the values from the right data frame. So you can also think of this data frame as what is blue in this figure. So here I deleted the observations that were associated with key A and B in the left data frame, and I deleted the observations that were associated with key E and F in the right data frame. So I only kept the intersection of the two data frames. We can also make a left merge. And that works the following way. So we use the merge method pandas and create a data frame called left merge, and then merge on these two data frames and merge on keys again. And now we specified explicitly that we want to make a left merge. And this is what we get out of it. So now we can see that we have all the observations that were originally present in left. We have the key A, B, C, and D. So 4 observations. We also have all the values that were associated with these keys. And then we only have 2 values from the right data frame. So that's 4 and 5. And the reason why we have not a number here is because there did not exist an observation in the right data frame that had key values A and B. So therefore, they are simply just given another number here. There are no data for this key in the right data frame. So what we did here is basically the following here. So we keep the whole left data frame, and then we add some additional not numbers for the right data frame for the keys that did not exist in the right data frame originally, and then we delete some observations from the right data frame. So what the observations that we delete, that's the values that we associate with keys that are not present in the left data frame. Okay, we can also do a right data frame, a right merge, and that works in the exact same way as the left merge did. The only difference is that we are now keeping all the information, all the observations from the right data frame and dropping some from the left data frame. Okay. And finally, we can consider the outer merge. So what this does is that it basically uses all the keys and it doesn't delete any information. It doesn't delete any observations. So the way that we get it is simply just by specifying how and then outer here when we create the outer merge data frame. So our data, when we make an outer merge, will look the following way here. So what we see here is now that we have a data frame with all the 6 unique keys that were present in either data frame left or data frame right. And then we have the 4 values that in the left data frame in one column, and the 4 values from the right data frame in the right column. And then we have these missings that are simply created from the fact that there is no value associated with key A in the right column, and there is no value associated with key E in the left column. So this is what happens here. So what we get is that we simply don't delete any information. We don't delete any observations. So therefore, there's no red area in this figure. However, there are these 2 green areas that represent these missing observations that we get out of doing this. Okay. In order to illustrate what we have in fact been doing, consider the following illustration here. So in these different figures, the left circle basically represents the left data frame, and the right circle represents the right data frame. And then what is yellow represents the observations that we keep in our output. So this is just representing what we just did in a Venn diagram. And here you can see that we are only including a small subset of our observations. Here with the left join, we are keeping all the observations in the left data frame. With the right join, we are keeping all the information from our right data frame, and with a full join, we are basically just keeping all our observations. So that's basically just recapping what I just explained before. Okay, so what I covered on the previous slides was the pandas merge function, which joined on columns in data frames. We can also join by keys in the index. So this is possible with both join and concat. And here I'll particularly focus on the pandas function concat, which is quite flexible here. So additional properties of concat on top of being able to, or by default, joining on the index is that it works both vertically and horizontally, and it works with multiple data frames at once. So we don't have to join 2 data frames at a time. We can basically join as many as we want. So of course, when we join either vertically or horizontally, we need either overlapping column names or index keys. Otherwise, this will not work. So in order to get started, I will now create 2 new data frames, df0 and df1. So df0 is just similar to the left data frame from before, but we have made the key into an index now, and we're doing the same thing with the right data frame from before as well, turning it into df1. Okay, so we'll first just briefly touch upon join. So this works like merge, but where key is now the index. So let's create a new data frame that we call inner data, where we use the join approach. So the syntax here is a bit different. So we specify df0.join df1. So we're joining df1 on df0 here, and we're specifying the one to make an inner join. And then we get the following output here. So we can see that this is indeed an inner join. It looks very similar to what we had before here, but the only difference is just the index. Okay, so this is fairly easy to do. The syntax is a bit different though. We can also use the concat function that you already used in assignment 0 vertically. So what I'll do here is that I'll make a horizontal join with concat. So that is, I'll make a join on axis 1. This by default works a bit similar to an outer join. So here first I'm making a list that I call dfs, which is a list of the data frames that I want to join. Then I specify pandas and then concat, and then I specify this list of data frames that I want to join as dfs here as the input, and then I specify that I want to join on axis equals 1. And then what I get is the following here. So as you can see, I have by default made what is similar to an outer join, right? This looks very much to what we had with merge when we made an outer join here. Again, the only difference is this key. We can also make a vertical join as you did in assignment 0. This is also possible with concat, but what we do here is basically just that we stack the data frames on top of each other. So I specify pd concat, and then I specify the data frames that I want to join, and then I specify outer and axis equals 0. And what I get is the following thing here. So this doesn't look very, very nice, right? Because the problem here is that df0 and df1, they don't share any column names. That's basically what I mentioned here. We need overlapping column names. So what we're basically getting is really just two data frames that seemingly have nothing to do with each other, that have just been stacked on top of each other. If the columns were called value in both of them, we would have something completely different that looked much nicer. Then we would just have one column with no missings in it. And if we hadn't specified an outer join, if we specified an inner join, for instance, we would basically just have nothing, because there are no shared column names in these two data frames. Okay, and here I'll just give you a brief overview of the different concat operations that we can make. So what we have up here is outer joins. What we have here is the horizontal join, and here we have a vertical join, and what we have down here is inner joins. And what we have over here is again the horizontal join, and what we have here is the vertical join. So I basically covered most of this, but I just wanted to pay attention to this specific illustration here. So here we can see that if we make an inner join that is vertical, we will only keep the shared columns in the two data frames, right? So let's now finally consider a practical example of concatenation. So what we're going to do is that we're going to load some stock data from Yahoo Finance. We also did that in the previous module, where we loaded stock price data from Apple in order to show you what time series data could look like. So here again, we're importing Yahoo Finance, and then we're also importing matplotlib for purposes of plotting. And here I create a list called stocks of the different stocks that I want to plot. There's the different stocks that I want to import from Yahoo Finance and plot with matplotlib. So we want to import Apple, Google, Microsoft, Amazon, Facebook, and Tesla. Then I define a function load stock, where I specify that I want to load data from stock prices from Yahoo Finance, and I only want to keep observations keep data or stock price that were observed from the 1st of January 2000 and onwards. And what I do down here is that I use this function to create a dictionary of all the stock prices for these different companies. And then what I do down here is then that I make a horizontal join to create a data frame that contains stock prices for all these 6 different firms from 1st of January 2000 and onwards. And I call this new data frame stock DF. So let's take a look at what this data frame looks like. Here I'm just displaying the 10 last observations of this data frame with the tail method, right? And we can see that these are very recent observations. So the last observation is from the 28th of July 2021. So I think that's from yesterday. And we can basically see that we have an observation for all days, excluding weekends. So if we see here, there's a gap of 2 days. That's because it's weekend, and there are no observations in on these two dates. And we have information for all these different companies. So I can also plot this data frame. I can plot each column in one joint plot here. So that's what I've done here. Here I have a line for each that represents the evolution of stock prices for each of these different 6 companies since 2000.